In this video, we're going to be finding derivatives of logarithmic functions by applying the logarithmic properties first. Now, for some of you that are thinking, wait a minute, sir, you already did a video on the derivative of logs, and I remember you saying that the derivative of the natural log of x is going to be 1 over x, and I remember that the derivative of log base a of x is going to be 1 over x ln of a. And I remember that video, sir, because you made a mistake on your formulas. You had this guy in the wrong spot. So what's the difference between that and this? Well, in these problems here, we're going to be able to simplify this problem first and then be able to take the derivative of it. All right, so let's go ahead and let's look at the objective for this video. All right, number one, state the 3 natural logarithmic properties. Find the derivative of a composite natural logarithmic function by applying the natural logs properties first. Okay, so in order for us to do this, we need to know the prerequisites, and the prerequisites is very simple. What are the 3 log properties that you learn in college algebra? Well, here we go. The log of a times b can be written as the log of a plus the log of b. Now remember, what are logs? Logs are really exponentials written in another format. So when I have something like this, when I have x to the a times x to the b, I'm really multiplying here. So what am I doing to my powers? I'm going to have x to the a plus b. See where the a plus b, that's where the plus comes from. Now on the second one, if I have x to the a over x to the b, how would you rewrite this? You would write it as x to the a minus b. So on the log of a divided by b, I'm really going to have the log of a minus the log of b. All right, and then finally the third scenario is, what if I have x to the a raised to the b power? That means that I'm going to have x to the a times b. So here what I'm going to do is I'm raising a to the b power. So that means that b is going to be moved to the front here, and I'm going to have b log of a. This one is the best property that I love. Of the 3 of them, this is the best one because it allows me, logs allows me to bring down powers. And you're saying, what do you mean by that? Let's pretend I gave you something like this, and I said 3 to the x is equal to 5. And I said, solve for x. And I said, well, the x is on top. How can I solve for it? Well, logs, if I take the log of the left, then I'm allowed to take the log of the right. So by using property number 3, that's going to allow me to put that guy in the front. So I'm going to have x log of 3 is going to equal to log of 5. Now I divide both sides by log of 3, and guess what? I just figured out what x is. X is going to be the log of 5 divided by the log of 3. And that's what I love about these properties. It's like, oh my gosh. Now, I have to go back and recall the derivative of the natural log. What's the derivative of the natural log? The derivative of the natural log is going to be a 1 over u times the derivative of u. Now this one is a little bit different of what I covered over here. Okay, here I have just 1 over x, right? 1 over x, and you say, hey sir, where did that extra part come from? Well, on this one, you need to understand that this is a quantity. U is considered a quantity. It's more than just a plain x. It could be x squared plus 5. It could be x minus 3. It could be 3x cubed. So it's a quantity, and that's why we're going to do one by the chain rule. We're going to have 1 over u times the derivative of u prime. Now, if I have it in this notation, if I have a log in a different base, remember that the natural log is going to be base e, and over here the log is base a. So I'm going to have 1 over u times ln of a times u prime. So it's the same concept, except that we're just adding an extra bit. We're adding this part, which is the natural log of your base. All right, so what we're going to do is we're going to do some derivatives. All right. I'm sorry, I have this one example, and this is not the chain rule. So what we're going to do is we're going to break this part. All right, I'm going to break this apart into using the properties of logs. So I'm going to have the ln of x plus the ln of x minus 7 plus the ln of x plus 3. Now what have I done from here to here? From here to here, I've done nothing but use college algebra. I didn't do any calculus. All right, so if this is y, this is still y, so now I'm about to do the derivative. So what's the derivative of this? The derivative of this is going to be 1 over x plus 1 over x minus 7 plus 1 over x plus 3. And that's it. And I'm done. You see? So now, let me show you why the properties are important. Let's pretend I gave you something like this. Let's say I gave you the ln of x over x plus 1. Okay? And according to my properties, I can break this apart as ln of x minus ln of x plus 1. And then the derivative of this would be 1 over x minus 1 over x plus 1. And I'm finished. Now, if I did not know that, okay, look at what I'm going to have to do. All right. So I'm going to call this guy my u. So this is my u. So the derivative of ln of u is going to be 1 over my u. So I'm going to have to put an x here over x plus 1. And then I'm going to have to multiply this times the derivative of this. So I'm going to have to use the chain rule. I'm sorry, the quotient rule. The derivative of the top is going to be 1 times the bottom of x plus 1 minus the derivative of the bottom 1 times the top all over the bottom squared, x plus 1 squared. Yeah. And now this guy, believe it or not, would actually, or I can actually rewrite this guy into this notation. So you tell me, which method would you prefer? Would you want to simplify something like this, or would you rather get this one? So using the properties is going to have some benefits. Okay, so let's do another one. Here we go. So here I have a over b. So that means that I'm going to rewrite this as ln of x plus 3 minus ln of x minus 7. And now I'm going to take the derivative. The derivative of that is going to be 1 over x plus 3 minus 1 over x minus 7. And that's it. I'm finished. Now, let's see. This was property number 1. I used property number 1. This one I used property number 2. Now I'm going to use property number 3. So what I'm going to do here is I'm going to rewrite this problem. I'm going to rewrite it as ln of x squared minus 5 to the 1/2. And now that I have the power here, I have this power right here, I can move it to the front. Okay? So that means I'm going to have 1/2 ln of x squared minus 5. And now I'm about to take the derivative. So the 1/2 is just a coefficient here, so I can leave them alone. And the derivative of ln of a quantity is going to be 1 over my quantity, right, times the derivative of my quantity, which is 2x. And now by simplification, I'm gonna cancel this out. It reduces to a 1, so I'm gonna be left with x over x squared minus 5. And this is the derivative of this. All right, let's try another one. Let's combine some rules here. So in this problem, if you notice, I'm combining. There's a division and there's a radical, so I'm going to be using properties number 2 and property number 3. So I'm going to rewrite this as ln of the cube root of 2x plus 5. It's not plus, it's supposed to be a minus, so it's going to be minus the ln of x plus 7 to the 7/5. Okay, so now I'm going to rewrite, I went ahead and I already did the rewrite here, so let me go ahead and just stick with the 5th root of x plus 7 here to the 7th power. Alright, so now I'm going to rewrite it. I'm going to say ln, that can be written as 2x plus 5 to the 1/3 power minus the ln of x plus 7 to the 7/5. Now remember what I said in a previous video. This guy is considered to be your root, and this is your power. So the roots we find, where do we find roots of a tree? In the bottom. So that's why we put the 5 on the bottom and 7 on top. Okay, and here's my root. My root is a 3, so I put it on the bottom. So now I'm about to use the properties of logs. So that means that I'm going to rewrite this as 1/3 ln of 2x plus 5 minus 7/5 ln of x plus 7. Now I'm about to take the derivative. All of this is all right here is algebra. All right, so let's take that derivative, And the derivative here, y prime, is going to equal to 1/3 1 over 2x plus 5 times the derivative of 2x plus 5, which is just a 2, minus 7/5 1 over x plus 7, and then you can say times 1 if you want. The derivative of x plus 7 is just 1. So that means that y prime is going to be written as 2 over 3 2x plus 5 minus 7 over 5 times x plus 7. And that's it. This is my answer. And I hope that your professors don't make you combine those, all right? Because that'll take more time than actually doing the whole derivative problem, all right? And that concludes the video.